Hello and welcome. I'm glad you're here. In this video, we're going to use machine learning to automate the creation of map features. We'll be using satellite data today. The subject of this study is a wildfire that was burning in California, southwest of San Jose, northwest of Santa Cruz, on August 20th, 2021. This is a visible light spectrum view of the fire. While this image is very dramatic, it's not helpful in addressing the urgent need to know where exactly the fire is on the surface. Luckily, the satellite has sensors that can detect wavelengths that are not blocked by smoke, and the satellite vendor sells a product consisting of 8 bands in the shortwave infrared part of the spectrum. The satellite data vendor provides the data as a series of bitmap raster images with pixel values representing the intensity of the energy received at the satellite. Let's briefly look through these shortwave infrared layers. Here at layer 1, we can see the texture of the vegetation. These gray spots are grass. Pay attention to these bright white spots as they change as we go through the other layers. As we progress through the layers, the vegetation texture gets harder to make out, but these bright white spots become more prominent. That's probably where the fire is. So now that we have an idea of the data available to us, let's go about mapping the fire. The satellite vendor recommends combining shortwave infrared bands 8, 6, and 1 to generate a false color image of where the fire is. Now, we're making great progress here. This image does a very good job of showing where the fire is compared to looking at the smoke. This is good, but I want to simplify this a bit. I want to create some simple shapes that can be incorporated into a map or some point coordinates that can be shared with a navigation system. In an emergency situation, we wouldn't have time to very carefully draw borders around where the fire is. So I'm going to use machine learning to help me out. What I want is for the computer to tell me where the fire is and, logically, where the fire is not. In other words, I want to sort these pixels into 2 categories. From the machine learning toolbox, I'm going to use the k-means clustering algorithm. With this algorithm, I'm not providing any training data to the algorithm. I'm not teaching the computer what fire looks like or what non-fire looks like. Instead, I'm asking the computer to sort the pixels into 2 categories, the members of each category being as similar as possible, and the 2 categories being as different as possible. I'm hoping that the spectral profiles of fire and non-fire will be so different that the k-means clustering algorithm will pick up on this and find the greatest contrast between fire and non-fire pixels. I admit that my idea depends on hope, and that hope, perhaps, is not a sound strategy to use in science or in commerce or in emergency management for that matter. But let's see what the computer came up with. This image is a bitmap raster image consisting of pixels with only two values, which I have colored green and red. Now, let's zoom in to perhaps the most important part of the fire. If I peel away my layer, I do see that this is where fire is most definitely occurring. It seems that the clustering algorithm picked up on the most intense parts of the fire, and the less intense parts of the fire along the image, it is lumping those in with non-fire. But I consider this to be pretty good. Now, we're not done yet. Remember, I wanted to create shapes that could be placed on a map and point coordinate features. I used the two-category raster that I created earlier as input for the geographic features of R. And this is what it gave me. It gave me this series of shapes that outline the fire. As I said earlier, it's only detecting the most intense parts of the fire, but at least my model does not have any false positives. For each of these polygons, I asked R to find the centroid of the polygon, and here I symbolized each centroid by a fire, and we can see up here even some small fires burning around. Now that we have shapes of where the most intense areas of fire are, we can incorporate those shapes into a map, say superimposing it on this USGS topographic map, and we can provide this map to the firefighters who are out fighting the fire. We also have a very neat list of the fire centroids. This perhaps might be useful to the pilot of the firefighting airplane because, bear in mind, from the pilot's point of view, all he or she sees is smoke. I accomplished what I set out to do. To review, we had an urgent need to understand what was happening on the ground, but our visibility was obfuscated by smoke. Luckily, we had access to some data on some wavelengths that are able to easily penetrate the smoke, and based on these wavelengths, based on this data, we were able to create a visualization. We were able to see through the smoke. Now, that was good, but we wanted to create, in GIS terms, vector files that were suitable for sharing on a map. We used the k-means clustering algorithm to sort the pixels into fire and non-fire, and based on that, we created a series of polygons and a series of point features showing the centroids of the fires. Well, thank you for viewing this video about my practicum project. I welcome you to peruse the rest of my site. It has a lot of very interesting stuff. See you out on the road.